Welcome to City Sailing Radar Course. In this video, we're going to talk about what we do when we see a target. We're going to plot it, its distance and its bearing, use the VRM and the EBL. We're going to wait 6 minutes and explain why, plot the VRM, EBL, and then we're going to plot it on a plotting sheet. And from there, we're going to work out the time of the CPA, the closest point of approach, and the vessel's course and speed, and what we're going to do within Rule 19 of the collision regulations. Here we go.
Okay, we have one target here. It's 6.03 miles away and it's on a relative bearing to us of 304 degrees relative to our ship's head. So as we carry on, I'll restart the simulator. We've got the time down here. We'll speed it up and see what it looks like in 6 minutes. So we'll stop it at 6 minutes and we'll work out whether this target's going to hit us. We can work out its CPA. We can work out its TCPA as well. We can also work out the target's course and speed, and also what we need to do with this target in relation to Rule 19. So we're just about 3 minutes, but we're going to run 6 minutes. But looking at the target is coming towards us, so it is a point of concern. It isn't parallel to our header line, and it isn't going the same speed as us. So we can say that this target is moving, and it's not stationary. So in a minute, if we resolve our course and speed as if it's a stationary buoy out of it, we'll be able to work out the vessel's course and speed. So we just came to 6 minutes. 6 minutes. So we can see here where it started, we can see here where it is now. So started off with an EBL of 304 and a VRM of 603. So on the 6 minutes mark, the EBL is 308 degrees relative and the VRM is 4.37. So we know where the vessel's moved in 6 minutes and we're going to plot it. Our target, we found its initial position and we found its position in 6 minutes. So let's plot the first position, which is at 04 degrees relative, 6.03 miles. So 304, so relative 0 at the top all the way around to 360. 304, 300, 1, 2, 3, 4 there. Mark that off, draw your line. There, and we'll measure the distance, so extend it out a little bit. So 304, 6.03, 6.03. So the scale here goes 1, 2, 3, 4, 5, 6. 6 is just off the end. So if I find 03 here, and we can just extend it off the end to where the position is. So 603 will be there. Second position, 6 minutes later, was at 308, which is here. So we just mark 308 on our plotting sheet. There. And the distance in was 4.37. So we mark 4.37 on here. 4 there. 1, 2, 3. 1, 2, 3, 7 there, and we'll mark that off from the middle on the line. So our second position is going to be here. So this one 0, 0, 0, 0. 6 minutes later 0, 0, 0, 6. If we join those two together, assuming that we're going to do the same course and speed, so here we go, join them together, assuming the same course and speed, we can find out our CPA and our TCPA. So CPA, we join them together. There we are now, just 6 minutes later after our initial contact. Join the two lines together, assuming we do the same course and speed and they do the same course and speed. We're bang on here, which is 1 mile. So 1 nautical mile will be our CPA. Okay, so CPA 1 nautical mile. Okay, the time that's going to happen, TCPA, Well, if we know this is 6 minutes, we can measure this one. Okay, so that's 6 minutes. So starting from now, that'll be 6 minutes from now, 6. That'll be 12 minutes and another minute on from there. So it'll be 6, 12, 13 minutes. 13 minutes. So TCPA, 13 minutes. So we know where this vessel's going to be and the closest it's going to be. So it's going to be 1 mile in 13 minutes. So we go back to what we did before with the stationary buoy. So if we draw a line parallel here, straight down, parallel here, okay, and we know our vessel's course and speed. So we know our vessel's course and speed. So our course is 040 degrees true. So ship's course 040 degrees true. Ship speed is 6 knots. Okay. So if we look at this and we're 040, 6 knots. So draw a line down there. If it was a stationary buoy, where would it be in 6 minutes? The reason we use 6 minutes is 1/10 of an hour. So in 6 minutes, which is divided by 10, 0.6 miles. So at 6 knots, 6 minutes would be 0.6 miles. So we measure 0.6 miles here. There we go, 0.5. 0.6 there. So if I measure that distance here, if it was a stationary buoy, as the previous exercise, it would have gone down this line here. So in 6 minutes it'll be there, 12 minutes will be there, 18 minutes will be there. But we're not interested in that. We're interested in where it's going to be in 6 minutes. So in 6 minutes the stationary buoy will be here. But it's not here, it's here. So that's the difference of the vessel. So if we were to draw those together, that'll be the bearing of the vessel. Okay, if we measure this distance, it'll be the speed of the vessel. So if we measure this distance here, measure it on here, so it's doing 1.5, 1.7 miles, multiply it by 10, it's doing 17 knots. So it's doing 17. So this vessel is doing 17 knots. Okay. So to find the bearing of this vessel, so if we were to look at it, the vessel won't be coming in this direction, the vessel will be coming in this direction. If we were stationary, the vessel would be coming in this direction, but we're not. But we've taken out from here to here the speed of our vessel. So instead of coming this way, the vessel will be coming this way. The faster we go, the more that moves around. So in this exercise, the vessel's coming in this direction. So let me draw him on in that direction. We know because we've measured this, multiplied by 10, that he's doing 17 knots. Well, what course is he doing? We'll look at this one. Big arrow in the direction he's going, little arrow to the top, and he's doing, line that up, and he is doing 090 degrees on here. So 090. If I was to then take this to here, 090 relative to us. Do we do plotting? Very rarely. Why are we doing plotting? Is to show you how we take out our relative speed, show you how we can work out the speed and course of the vessel. So it's relative 90, we can work that out. So when we flash on our ARPA here, and it gives the circle and the line here. I've just shown you how that works that out. What do the rules say? We must take systematic bearings. We've done systematic bearings, so we've worked out it's TCPA, it's CPA, TCPA, course and bearing. So what do we do within the rules? So the vessel's coming port side, what we do is avoid an alteration of course to port. So rule 19 says in restricted visibility, when one vessel cannot see the other vessel, when the vessel is coming from forward of the beam, we must not alter course towards them. So if we are to alter course, we alter to starboard. So from here, we'll alter to starboard. Okay, thanks very much. Talk to you later.
Thank you for watching the city sailing videos and tutorials. We have plenty more on radar. Please come along to a radar course if you want a certificate and use the radar simulators and plot with an instructor in the classroom. We'd love to see you. Thank you very much, and we'll see you soon. This is City Sailing out.